Ladies and gentlemen, welcome back to the Crypto News Podcast. It's your host, Matt Zahab, and we are buzzing as always. And I am super pumped to have one of the OGs. Now, when I mean OG, this guy is a true original gangsta. May or may not have worked on the first smart contract in the whole friggin' world. And I'm not talking like, you guys are probably thinking, oh, it was in 2010, a couple of years before ETH was created. No. This was before I was born. This is a very OG smart contract. We're gonna get into all this. But before we do, the star of the show today, we have Dean Tribble, the CEO of Agoric OpCo, the software dev company supporting Agoric, the JavaScript smart contract platform and proof-of-stake blockchain. Dean drives the vision to build a safe and composable JavaScript smart contract platform to onboard the next 14 million developers into Web3. As discussed, Dean is a literal OG cypherpunk and pioneer in distributed systems and smart contract technology, as he may have literally worked and built on the first smart contract ever. Also had another company called Agorics, where he was CTO, and it got acquired by Microsoft. Ever heard of him? He was also CTO of VerifyValid and VP of Deluxe, where his echeck systems have carried billions of dollars. We have a true OG on the pod today, and he has one of the most electric mustaches I've ever seen in my life. Super pumped to have him on. Dean, welcome to the show, my friend. How you doing?
I am doing great. Thank you so much for having me. I'm excited to be here.
Super
I occasionally say yes
too.
when this mustache is older than Vitalik, but
I love it. Dean, super pumped to have you on here, my man. You have an incredible background, and sometimes we get the term OG thrown around on the podcast. And I usually refer to those as like OGs in the crypto space, where they got in between 2010 to 2013, 2014. They've been in the space for a decade. In the crypto space, that would usually quantify you as an OG. But when we talk about smart contracts here, you told me before the show that you worked on the first smart contract in 1989. That is friggin' bananas. Dean, I was born in 1995. So this is...
I was young. I was like 3 years old. No. So
it's crazy.
The first production smart contract. I don't know what people were doing in labs, but this was deployed to production with paying customers, running pre-internet, pre-web. You dial up on your, on whatever it is, 1200 baud modem to connect to this thing in order to, orchestrate. What's a smart contract is sort of the heart of this. Software that is enforcing the terms of a contract-like arrangement between third parties, right? So eBay, PayPal, Venmo, Airbnb, Uber, Lyft. Those are all smart contract businesses. So smart contract was $1 trillion market cap before blockchain came along, right? It's about the role of the software to the customers. And so it enables strangers to cooperate. And that's really been our vision, our mission for now literally decades, is software enabling strangers to cooperate, right? Millions of people buy things from strangers that they probably wouldn't like if they met them in person. And it works every day, all the time, because software is orchestrating and enforcing the terms of the exchange, the delivery, the monies, all these kinds of things. There used to be a comedian that would do an act of, okay, so I'm going to summon a stranger to my house, climb into the stranger's car and have them take me someplace that I don't know where it's going and I've never met this person. And if you told someone 20 years ago that people were going to be doing this all the time, every day, they would look at you like you were crazy. And yet, because you could build software in the middle that could orchestrate and add safety and security and, an investigation and background and all these things, now people do that routinely all the time, orchestrated by software enforcing the terms of that engagement. And so it's huge business, it's huge value. It's really changed the face of the world and how we do business. And the first production one of those, that was really thought of itself as smart contract logic that was doing this sort of thing was the AMiX in 1989. And I helped get the smart contract part of it right.
That's wild. How does building present day smart contracts on Ethereum and Solidity differ from the first one you ever built back in 1989? I mean, I'm sure absolutely every component is different, but I'd love if you could walk me through some of the biggest differences here, Dean.
So first there's what's the big difference of having blockchain. So forget any of those things, right? Blockchain, we've got replicated execution on machines that are in different jurisdictions and different, administered by different independent parties. And they're all checking each other's work and coming to consensus about what happened. And that difference means that now you can run software with a level of integrity that did not exist before blockchain, right? You're not trusting any one party. You're not giving a backdoor. If you do it right, if you really decentralize, you've got this environment where you really can rely on the software. So now you can have smart contract businesses without a trusted intermediary like eBay or PayPal or Venmo or Airbnb or StubHub or, and sometimes they take huge chunks, 35% of your ticket sales. Sometimes they do illegal things like Enron did, where they were a trusted intermediary for electricity trading. And it was a huge value potentially to the world. And they got greedy and started slipping in trades, after in theory businesses closed and they were manipulating the market and all these things that a decentralized transparent system, they would not have been able to do. Right. And so being able to eliminate the trusted intermediary by having software itself be what you rely on to enforce the terms of a contract-like arrangement is what enables the Uniswaps and the everything from, sort of a smart contracts on Ethereum to rich and, more programmable environments like Agoric. All of those are enabled by being able to run software with high integrity, which we weren't able to do anywhere near this safely before. So that's the first thing, is blockchain makes a difference there in terms of what you can do. Now, the thing about Solidity is it was hugely important in making that shift, right? Run software in an environment where it can't be tampered with, by any individual organization or regime. And that's really important, right? Because, at the level of scale, we're talking about re-engineering how humans cooperate. Regimes do intervene, right? And whether it's, Venezuela or the US government, doesn't matter, right? If you're on the other side of it, it's not a comfortable place to be. And them being able to backdoor stuff so that you cannot rely on the software that's executing would mean that software cannot provide us the kind of safe environment that if I physically meet you at a swap meet and trade something with you, I've got control of what's going on, right? And it doesn't mean, necessarily that I've got all the, it's not necessarily the, Tim May cypherpunk world, but it's got to be higher assurance than what regimes tend to want to have happen. Okay, so that's the first. Then there's the programming environment. Now, I compare ETH with Flash, right? If you remember Flash, you were just barely old enough. No, sorry. You remember Flash, all the marketing sites were Flash, all the internet games were Flash, right? 100%. That was how people built interactive, whizzy things, right? And it had, one of the things that a prior company that was inspired by the same papers, right? So Agoric, by the way, comes from the Greek word agora, which means the open marketplace. And so in 1986,
I like that.
Mark Miller, it's lovely. And we tried various, Grecian pillars as logos and stuff like that. But anyway, so Mark Miller and Eric Drexler wrote a paper called the Agoric Open Systems paper that really shared a vision of software agents creating and participating in markets. And that was a big early piece that shows up on A16Z's crypto canon. It's one of the real inspirations for Nick Szabo, who worked with us at the time, and various others, Hal Finney and so forth, for how to build software, how to build large scale distributed systems. And so we had a prior company called Agorics that was building smart contracts at SunLabs for doing control of network systems, control of network resources, compute resources, and memory, and satellite dish time, and all these kinds of things, right? So it was an early smart contract environment. And so that was, an area of getting software to enforce the terms of contract-like arrangement between third parties, where those third parties might be software agents, they might be AIs, or they might be people. Right? Or they might be businesses, or they might be any of these kinds of things, but you really want to be able to have a level, smooth playing field where all of them could work together. So one of the things we did, because, the Macromedia Flash was trying to be able to do this desktop thing where you could pull in software from lots of third parties and run it. And they were having problems from a security point of view. So they brought us in to audit that their computational model and how you do that. And one of the things we discovered was, reentrant, synchronous reentrant call and message.sender as a security model were both really problematic, real security hazards that humans could not get their head around, right? And so we saw this in Flash, which was the dominant programming language for large-scale interactive experiences on the web. We saw this in Flash, and it was really harming the ability of Flash to grow. It was the brick wall that Flash programming is running into. And EVM has all those same properties. It was inspired by that work. It built along the same properties because they make simple things simple. They just make hard things essentially impossible. And so we're now very early in the world of programming, right? I mean, there's a lot of money in blockchain, but we're very early. I mean, AMM, Uniswap, that's huge. It's a lot of money. It's a really simple program. It's a few thousand lines, right? I mean, it's just, we're not really doing yet large scale distributed applications on blockchain. There's an economy there, and that's really important and valuable. And I don't mean to deride that at all, but it's all very transactional. It's all, I do one transaction, I can figure out what that looks like, and then we're done, right? But most software doesn't work that way. You don't do, large scale collaboration on a whiteboard using, transactions, right? You do it using long-lived experiences, long-lived software activities and that sort of thing that just don't work well on current blockchain. So back to your current question. So the programming model is pretty weak. It has fundamental security hazards that are very dangerous. The biggest difference in blockchain world, in some sense, versus Web 2 smart contracts is Web 2 smart contracts. I'm hosting my environment, running my program to provide a service to my customers that is a smart contract service, but it's still, I'm in control of all the software I run in my environment, right? And that means that I don't have a lot of security hazards of running third-party code and having third-party code all cooperate with each other and attack each other. So, the developer deploying to a cloud service, they're generally not deploying where they're also embedding third-party code. Or at least that's the theory. And let's come back to that in a moment. But in the cryptoverse and in blockchain, you're deploying in a hostile environment where, because of pseudonymity and anonymity, it is very easy for attackers, if there's a hole in your code, to exploit it.
Works of magic.
And because, and because money shows up there first, and there's good reason why money shows up in the cryptoverse first before lots of other ways we might leverage this software. Because money shows up there first, it's a rich target. So you've got an immature market with platforms that have fundamental security hazards that are hard for humans to reason about in a hostile environment. And so that's been an interesting adventure and breeding ground and stuff like that. We've got, people talk about ETH as sort of the proven battle-tested. No, it's lost $9 billion. That's not battle-tested, that's you lost. And so it's one of those things where it's a hostile environment, it's a dangerous environment. We have much better techniques that have been deployed there that are one of the reasons why we built Agoric, and other people have built other technologies to solve other parts of that hard problem. But that's one of the ways in which it is a different environment, is that you're going out into a target-rich environment, as it were.
100%. Great spiel there, Dean. Let's speaking of Agoric, let's jump right into it. Give me the elevator pitch. Give me the 30-second TLDR. Too long, didn't read. Elevator pitch on Agoric, and then we'll get into all the fun stuff, because we have we have MetaMask snaps to talk about. We have your mainnet 1B partnership with BitGo, IST, Shade Swap. You guys have been absolutely launching stuff left, right, and center. Before we get into all the cool launches, though, give me the elevator pitch, then we'll get into it.
Sure. And then to ask me in a month, the elevator pitch will change just a little bit. So let me tease that. The hardest thing to scale is developers. Right? You can sort of scale users with one app that lots of people want to use, but that doesn't scale the platform or the economy. For that, you need to scale developers. You need millions of developers if you're going to get where a business that wants to roll out a website also wants to update the smart contracts or do something a little bit custom for their special business. And you don't take over the world, you don't take over the economy, you don't take over how people do business unless all the developers on the planet can build this stuff. Right. And that's, Web 2 is all over the world because millions of developers can program it. And so, to do that, you have to meet developers where they're at, and you have to meet them with an abstract enough model they can program to it. They don't care in the mainstream about whether it's ETH or Solana or Agoric or Cosmos or whatever. What users care about is the experience they can get, and they care about it being safe, and they care about it being usable, and they care about, these, all the things that they care about in Web 2. There's nothing magical about Web 3, except that you have early adopters that care to make sure it's decentralized and private and enables them to do things that they weren't able to do before. But as you start expanding that out, these fundamental basics of, it's got to be usable, it's got to be focused on my benefits are fundamental. So we enable the world's developers to be able to approach Web 3 And we enable it in a way that through our system, they can orchestrate, they can coordinate activity across lots of assets, across lots of chains, without it being something they have to think about very hard. That ability to rapidly build rich, complex, interesting applications is something that has not been available to Web3 before, and that's what we bring to the table.
Super, super interesting there. And the name, I love the name too. It's what is it about like everyone stealing names from Greek, from the old Greek language? Like they all slap too, though. You know what I mean, Dean? Like yeah, I love it. But anyways, let's.
Okay, so Agoric was one of the early ones, right? That was 85, 86. So, but by the way,
that's very true.
It was originally inspired by using markets to control resource allocation in software, right? That computers were crossing the threshold where instead of talking about, tens of bytes or hundreds of bytes, or maybe 640K was a big machine at the time, right? Instead of talking about that, you're talking about gigabytes and terabytes, and now you can't manage all of that yourself. How do you do that? And that's where Agoric came from, was use markets to bid for compute cycles and memory and network space and stuff.
Is that a little off topic here, Dean? But is that sort of similar to what we're seeing in the AI space with all the race for GPU power?
Yes, actually very much. And it's another one of those things where there's demand for a resource, there's a lot of it. You're not going to manage individual GPUs. You want to manage them by large swaths, and you want to allocate them to where they're valuable for. You would like to do that in a way so that people can get large volume, but small players can still come in and get high value volume. Microeconomics and markets are great for that. And they're better than all the central planning fallacies that governments across the world want to use for how to allocate resources. Markets are just great. And so using them for allocating compute resources for high demand is really valuable. And that's why EIP, 1557, right? The market-based allocation of block space, one of the contenders was an algorithm from the original Agoric open systems papers, right? The escalator algorithm was designed to show how you could do incentive analysis and mechanism design for using auctions to do compute resource allocation. And we now see that showing up for block space auctions in blockchain.
So cool. Dean, let's jump into MetaMask Snaps here.
Absolutely.
MetaMask has introduced Snaps, which is an application built to add extended features and functionality to MetaMask. MetaMask is one of the most popular and important apps to the blockchain space as a whole, minus the whole seed phrase part. It's pretty darn easy to use. It's pretty darn efficient to use. I personally think we need something a little bit better to onboard the masses, but in regards to MetaMask as a whole, it is a pretty friggin' darn good app. And I'm sure a lot of us are very grateful to have it. You and the team worked your tails off to help launch MetaMask Snaps, and I'd love for you to talk about it.
So remember earlier I mentioned, deploying Web 2 apps is not the same hostile environment, right? You're not running third-party code in your application. But in fact, you are, right? Because, the study of all these apps says that only 3% of the code in some large-scale deployed web apps, and typical across GitHub, only 3% is actually application code you wrote, and 97% is libraries you got from somewhere else. So there's this big supply chain of how do you trust those libraries? How much authority do those libraries have? And in typical web architecture, they have all the authority of your application running, and you've got complete exposure to all of that code. And Kumavas, Aaron Davis, one of the founders of MetaMask, was concerned about that. He was concerned about their software supply chain. And so he and Dan Finley searched around, and they saw what Agoric was doing for hardened JavaScript. It was called SES at the time. And that's been an effort that was one of the things that led to Agoric. It's been an effort over the last 15 years. Mark Miller, our chief scientist, has been driving into the JavaScript standards the elements to be able to do large-scale safe programming where you're not completely exposed to every library you try to use, where you can grab something and say, here's the authority you have and no more. And it's easy to program that. You just, when I load a clock, it needs access to the timer, but it does not need access to Unix exec. It does not need access to my password file. It does not need access to my keys. It doesn't have to encrypt anything. It just needs to read the damn time, right? And so when I created, I wanted to be trivial programming behaviorally, so it gets the authority to read the clock, and that's it. And now I can ask it the time, and it could lie about the time, right? It could be a bad clock, but it can't lie about the time and, oh, by the way, send my password file to another country, right? Because it just loads with just the authority it needs in a natural programming style. And it does not check that the guy asking for the time is one of those people that's allowed to ask for the time, like the message.sender silliness that you get from Flash and Solidity and so forth. And, because that's just a terrible model for composing libraries into larger applications. The model is, I launch you, I give you the time thing, and now you can tell me the time I want. You can format. Oh, I want to give you my location, my locale, so you can format it in international form. That's great too. You don't get to sniff around my disk and decide what area I'm on. You don't get to look at the geo unless I give it to you to decide what physical location I'm in. It's like, I'll tell you where I'm at. You just give me the render. And so they reached out to us and we connected on that. And that was the basis of the JavaScript execution model that we're running on a blockchain, where we natively execute standard JavaScript just in a deterministic fashion, so you can run it on 100 machines and come to the same answer, even though you're running it at different times in different locations. So hardened JavaScript is, the way I refer to it, and the way to think about it is, it's the JavaScript you thought you were programming in already. It is the version of JavaScript that does what you expect when you're doing things. JavaScript starts out very malleable, right? You can change what it means to iterate an array, to walk through all the elements of an array and print them out or format them or do something with them. And the problem is, you can change that to, oh, by the way, read the file system, copy a file, and send it to another country, right? And that is not what I expect when I iterate an array. That is not what I expect when I print a message to the user. And so what hardened JavaScript does is it locks down the world so that the array iteration or printing a message to the user does what I expect. It does what the standard says. So JavaScript starts out very malleable, which is useful for certain kinds of things, but almost no application actually needs that or wants that. What it wants is the JavaScript programming language that they are all programming in. And so that's what hardened JavaScript is. And in that process, we lock down all of the security hazards that people sort of think of historically associated with JavaScript, but they've been locked down for a long time. It's just people sort of still have this, racial memory of early days of JavaScript. But JavaScript, every day controls trillions of dollars of transactions across every facet of human existence. If it had big security hazards, people would, not be doing that, and they'd know by now.
Well said there, Dean. We got to take a quick break and give a huge shout out to our sponsor of the show. But when we get back, we have to discuss your guys' massive partnership with BitGo and, of course, BLD staking, which is pretty freaking cool. Until then, huge shout out to our sponsor of the show. That is Prime XBT. We love the team at Prime XBT as they offer a robust trading system for both beginners and professional traders. It doesn't matter if you're a rookie or a vet, you can easily design and customize your layouts and widgets to best fit your trading style. Prime XBT is also running an exclusive promotion for listeners of the Crypto News podcast. Use the promo code CryptoNews50, that is CryptoNews50, all one word, to receive 50% of your deposit credited to your trading account. And now back to the show with Dean. Let's jump right into the partnership with BitGo and you guys integrating BLD. This is massive for institutional adoption of DeFi. Tons of financial institutions want access to creme de la creme grade smart contracts. They don't have the wherewithal or the know-how and the resources to do it themselves. So they piggyback off of people like yourselves and your team. You got to love to see that shit. Walk me through the partnership here. What is the importance of partnering with BitGo? And walk me through a little bit more, because full disclosure, Dean, I don't fully understand the whole BLD staking and how that helps, but I'd love if you could walk me through why the partnership with BitGo and the importance of the BLD staking as well.
So first, BLD is the native token of the Agoric chain. It's, if you will, the foundation on which the economy is built. So it provides governance. It provides, it's how you can get a account abstraction, wallet set up, which we've had forever. It is, an element that is used for getting rewards from the system. And the design of the Agoric system is a two-token world where BLD is at the bottom, and that's the foundation on which things are built. And IST, interstable token, is a stable token natively built in JavaScript using all the best practices of over collateralized, backed by crypto assets and other stables. But it's all designed, the infrastructure and platform is all designed natively to include async network access, async, secure access to assets on other chains. And so the, ISD stable token, for example, can you pull over Atom or staked Atom, the some of the staking derivatives or Osmo or various other things, assets that the community will decide are appropriate backing, use those as collateral, and mint the stable token IST, and then you can take it to other chains across the ecosystem, not just use it on Agoric to pay gas fees or pay for network services, but buy NFTs on Stargaze and Omniflix or buy assets in Osmosis or ShadeSwap or other places. And so, it's a stable token that is, starting out on Agoric, starting out designed for the connected interchain, bridging across. It just went live on StellaSwap on Polkadot, I think. And so it's sort of appearing and spreading outwards because it's very focused on being about sort of the chain abstract world, the world where, I've just got robust stuff that's running on robust systems, providing services to users. I don't care where it's running. I want to be able to pay for it with the same kinds of mechanisms. I want to be able to access assets on, Aave or Solana or wherever it is and roll them up into complex, interesting interactions that needs to be programmed in, sort of the Agoric nice async smart contracting model and so forth. So Build is the fundamental token that lets institutions and whales and others participate in that new foundation that will be rolling out and ramping up this year. That's why it's exciting for them to have access to Build. Is that something that as we start connecting to Web 2 and getting some of these Web 2 interested parties able to now start participating in Web 3, start to build in Web 3, that's interesting to institutions that, here's the place that they'll be able to participate, they'll understand how to do so, and that lets them participate economically as well. And the economy that grows with ISD, the economy that grows with functionality on the Agoric chain and with being able to coordinate access to assets on other chains, that economy, it pays rewards to Build holders that stake. So that's where the staking comes in is, the way you really participate, you get Build, you stake it, and now you go deploy your thing and you're going to get rewards from the overall ecosystem based on the ongoing usage and growth of the platform. And we're very focused on it tying to usage and growth, right? The important thing is that participation be aligned with growing the economy, with growing participation, with growing activity, as opposed to aligned with charging rents for people to come on board, right? One of the things you see in a lot of these chains, there'll be an underlying token. ETH is the canonical example, but it's common, and it's useful for starters, where you pay gas fees on Ethereum in ETH. Right, ETH is a volatile commodity. It's different yesterday from tomorrow. It's subject to lots of market fluctuations, and yet you're paying effectively your postage bill or your rent using these volatile assets. I mean, that's like paying for your rent with gold or with Apple shares. You can do it, but a few thousand years ago, we realized that an economy that used stable units of account and stable currencies for paying for services and long-lived contracts was a better economy. Right? It had less friction. It made it much more plausible to do some of the kinds of things I talked about that you can't easily do in crypto right now, like long-term contracts, subscriptions, mortgages, these things where, I'm not going to cut a mortgage in ETH that I'm going to be owing a certain amount of ETH in 40 years. That would be crazy. I have no idea what ETH will be worth in 40 years, right? But I kind of have an idea of what the dollar will be worth or the euro or anything that's designed to be low volatility. Yeah, it'll go up smoothly, but it'll still be sort of a predictable thing. So I can write a long-term contract. I can hedge a long-term contract. I can trade off different things. So you really want your economy to be in terms of stable units of account, of things with low volatility. And so we want that to grow. So the reward to the Build stakers, where Build is, this token that is intended to be able to grow with the size of the economy, it provides rewards for the economy growing, the amount of IST transacting, the amount of economic activity, not just the amount of thrashing of computers happening. And so that means it's the equivalent of paying your rent in dollars, not paying your rent in
that's huge.
Whatever. So back to BitGo. So the thing that BitGo brings is they bring a network of 1,500, institutions, whales and exchanges. And so that provides much better, much richer, much easier access to build for the larger world of economic participants in crypto and growing. They also they also work with, and this is one of the places where it's just so exciting to find this alignment, where they work with major brands and sort of, enterprises and, small and medium companies as well. But they work with Web 2 companies. They work with traditional companies that are trying to find their way into how can we work safely with crypto in a way that brings its value, but keeps us in our lane producing value that we need to for our customers. And whether that's, the Nikes of the world that are dipping their toe into NFTs to celebrate activity, or NFTs to provide access to events and access to private content, those are really valuable, but that's not something that they should dive directly in and expose themselves to the kinds of regulatory thing that BitGo is already expert at, right? And a lot of us are already experienced with. And so working with BitGo, aligns well with we're an ideal platform for Web 2 applications to start getting, to start moving over into Web 3 and adding Web 3 capability, because you're already programming in a language that they already know. It already works with their existing tools, VS Code and WebStorm. It uses, the best in practice style of programming of libraries with components that you can reuse. And those are things that the rest of crypto just doesn't really have. And it's sort of the bar that Web 2 programmers kind of expect. And this is one of the ways that, we are one of the fundamental bridges for getting, crypto access out to the mainstream world of developers, and giving mainstream developers the ability to get in, try things without having to spend 6 months learning a language that they might never want to use again, right? Instead, let's just use the stuff they've got and meet them where they're at. And so, so partnering with BitGo, we just got a bunch of opportunities there.
100%. Dean, you've been on a roll here. One more question, and then we will wrap up, as we are getting a little tight for time. Bitcoin, absolutely massive right now, more powerful than ever with the recent ETF news. We love to see that. You're big on institutional adoption. You guys are doing a bunch for institutional adoption of DeFi. We just talked about that with Agorics' partnership with BitGo. Let's jump into Bitcoin in particular, and something that you guys are doing, which is the Babylon integration for Bitcoin timestamping. This is a little above my pay grade. I don't completely understand the importance of this. I'd love if you could dumb it down and explain it to a non-dev guy like myself. Walk me through this integration, this partnership, and why and how Babylon integration for Bitcoin timestamping is so important.
Sure. So remember I said the value blockchain brings is multiple machines in different jurisdictions, running the same stuff and coming to consensus. There are lots of different mechanisms for consensus, and that's getting faster and stronger and better. So Bitcoin has the granddaddy magic that Satoshi brought to the world, which is this proof of work consensus, right? So the simple thing, people, when they hear about consensus, they think voting. Right? I've got an electorate, there's an issue at hand, they vote. The issue might be, did Dean win the election or did he get his money back? Because in Agoric, it's one or the other, and I can't get rugged, right? But it's a bunch of machines that they vote. And if I know what all those machines are, I can count the votes. Okay, now it turns out to be much more complicated than that, because I can count the votes, but why should you trust me? So instead, there's these weird protocols so that all of them count the votes, and they come to agreement that they all agree that Dean won the auction or whatever it is, right? And so that consensus is critical for decentralization. It means that compromising some subset of those machines, you can't compromise the integrity of execution, because 2/3 plus 1 will still vote that Dean won the auction, and the people that some organization compromised, well, they just end up getting voted off the island, right? Because they're clearly out to lunch. And so that ability to, if I can name all the machines they can vote, is where proof of stake and these very fast finality engines come in. But what Bitcoin came up with was before we knew how to do decentralized proof of stake. And there's still, people wonder about it. It still means that people with money could do the staking. And there's, always concerns as we continue to try to push the limits of how sure can we make it that these are not subject to compromise. The thing that proof of work does, in Bitcoin in particular, is it has a model where machines can come to consensus without knowing all the machines participating. right? So there could be 10,000 machines participating, none of which I've heard of, and yet they can come to consensus. And it sounds like magic. That's why I refer to it as the proof of work magic that Satoshi brought to the table. It really was important and novel. That was a huge contribution to the world's ability to do safe computation. And so it continues to exist. One of the values of Bitcoin is that it kind of is the same thing. It's kind of stable over time. It's not evolving rapidly to adapt to what it is we need right now. It is, people like to refer to it as money. To my perspective, it is not a money. It is an asset. It is like gold. Its value may change, but it is this valuable asset that they're not making, at some point they're not making more of it. It's clear how much it inflates, all that sort of thing. So it makes a great asset on which to base things and so forth. And so it has this novel security model that is time tested, is well understood, and really seems robust and will be robust going into the future. The nice thing about what Babylon brings is, let's take all these additional things that people are doing for faster performance that we all think is secure. But like any crypto algorithm, you think it's secure until it's not. And so one of the nice things that the Babylon chain does is it brings back all of those things and links them back to the granddaddy security model of Bitcoin. And you don't really want a lot of proof of work chains because it's slow. It takes a long time to be sure it's gotten to finality. It's power intensive and so forth, but it is uniquely powerful in the assurance that it gives you. So by being able to link all these novel things going out there back to the security of Bitcoin, you now get all the security weight, all of that assurance that Bitcoin's expensive security model provides. You can now provide it to all these much faster, much lighter weight, much more expressive systems out there like Agoric. And so, it's one of those things where, did we need it now? No, you don't need security until, oops, I wish we had security. You need it before, you need to put it in place before you need it. And, since this is a year where like the ability to abstract across chains, chain abstraction, right? Agoric is a key part of the future of chain abstraction, the future of making it so that people coming in, they can just experience all these assets and services without thinking very hard about where they're at. You were a key ingredient of that. We could ramp very quickly, and having that security in the bank, as it were, having that underpinning there in place is really a nice thing to have, right? It's a nice value to be able to lean on when we need it going forward. So that's why that's exciting. Then, additionally, it is an example of this, this broad connectivity, this ability to orchestrate across chains. And so the ability to have Bitcoin and start to access it as an asset value, Babylon is a great example, one of the earliest of, hey, this asset out there, we can apply it in ways that don't compromise its integrity, but instead leverage it, right? To do these other things, starting to get it in where, Bitcoin is the token that everybody knows already. JavaScript is the programming language that everybody knows already. The future potential of pulling those together. And I note incidentally that BitGo is the one that does wrap Bitcoin. So the future potential of being able to enable all the programmers in the world to program the main asset they've already heard of, if they've been hiding under a rock or hiding in an IT group somewhere. That's the kind of thing where opportunistically, that could easily become really important.
I feel like you may have just hinted at something. Dean, this has been an incredible episode. Thank you so much for coming on. I wish we had a little more time. We do have to wrap up, but I can't wait to have you on for round 2 because I know we literally barely scratched the surface here.
We will have more to say to you in a month or two.
100%. And we're going to have you back on because you're a great storyteller and you explain things in a great way. Really appreciate you coming on. Before you go, Dean, can you please let our listeners know where they can find you personally and Agoric online and on socials?
Absolutely. We are agoric.com or @Agoric on Twitter, X10, whatever you call it. I'm Dean Tribble on several different platforms, especially Twitter and Telegram. And absolutely reach out to us on, Discord /Agoric.com/Discord, Agoric.com/Telegram, Agoric.com/whatever your favorite thing is. And if you're a developer, docs.agoric.com. Any developer out there that's ready to, an entrepreneur that's ready to build something, we're the place for them to start.
Love it. Dean, thanks again. Appreciate it. Had a blast. Can't wait for round 2. Wishing you and the team all the best.
Thank you so much, Matt. And thank you for having me. This was great.
Folks, what an episode with Dean. Tribble, CEO of Agoric. He was on fire today, dropping knowledge bombs. We discussed a little bit of everything: distributed systems, JavaScript in crypto, MetaMask snaps, institutional adoption of DeFi, just to name a few. Dean was absolutely on fire. We'd love to see that. Huge shout out to the team for making this happen. Huge shout out to the listeners. Love you guys as always. Eustace, my amazing sound editor, appreciate you, my man. And listeners, back to you guys. Love you guys. Thank you so much for everything. Keep on growing those bags and keep on staying healthy, wealthy, and happy. Bye for now, and we'll talk soon.